October 10, 4 o'clock. So this part, the IRF 640N, arrived yesterday, so I'm going to install it into the SNAT. So I tested the source to drain impedance or resistance. It's in the mega ohms. So this is okay part. So the MOSFET is installed, and I checked the system. I took out the display from the housing. It was just too hard to work. So there's no power. I made up a portable power supply. I bought this from Lazada. So I connected the 24 volts, did this and that. I actually reverse engineered some of the circuits. It still doesn't work. So I realized the PWM chip is damaged. So I'm waiting for the parts to arrive from Shopee. I found it in Shopee. So just for the fun of it, knowing that this diode is a 12 volt, power up the 5 volt regulator, that's why there's 12 and 5, I decided to connect a 12 volts actually to the diode. So this is what happens. So it makes some rude noise, and it does what it does. So it looked like the circuit board works. Well, it's not that it looked like. It means that my diagnosis, where the fault mode is actually this chip. So that's the reason why I couldn't yet fix this, because I studied the chip a little bit, the data sheets, and some of the signal are incorrect, and so that's why this is the problem. So I'm waiting for the chip to arrive. October 14, 8 o'clock. The TC3845E arrived yesterday from Shopee. So I'm going to replace the component from the SNAT inverter. Replacing a surface mount component, typically I would just cut off the leads. I just don't have the cutter for this, so I'm just going to use a heat gun to remove the component. So here the bad component is removed. I think it's bad. I don't know. I'll find out once I replace. So I replaced the chip. Hopefully I did it right. It's hard to tell. It seems like it's soldered, the pins. And I have a power supply with 24 volts and 12 volts. So I'm connected the ground and the 24 volts. And I'm just gonna power it up. Okay, there's power to the system. So I'm going to turn it on and see what happens. Nothing happens. Well, that sucks. So when I was removing the chip, R89 was damaged, or it was already damaged. I didn't know it. And so now I have to replace that. Now I don't know what the value is. I should have checked it before. Anyway, it was broken already. So now I just have to figure out, or actually do some calculation and figure out what R89 should be. So it looked like it's a CC0805 component size. These are, I don't know, I used to know the size of these components. Now I don't, too old. So I'm just gonna go check the data sheets of this chip and what is the driving resistance to this component is. That's why it's not working. So going by the data sheets, the R89 should be 22 ohms, around there. It's a low value ohmage. Well, I asked myself, where am I supposed to get 22 ohms? I mean, there should be a gate resistance to limit something. Just for shit and giggles, I'm just gonna short that and then remedy that later. I just need to know that this system is working. So I basically jumpered the resistor R89 with this. It's temporary. I'm not gonna make it permanent. I have to buy the R22 from Lazada somewhere. So with everything connected, powered, I'm just gonna see what's going on. Nothing. Well, that really sucks. Oh, nothing, because I disconnected cables. I'll reconnect them. Okay, I missed to reconnect that. Okay, let's see what's happened. Nothing again. So what's up? So I'm gonna do some diagnosis. So during my diagnosis, I noticed there's a voltage on the source, and the source pin is used as a feedback with the resistor like this. This became open circuit. So there was a voltage at the source, which is feedback to the controller, which is used as a current sensing component. And so that's because it's too high, it stopped the chip from driving the MOSFET hard. So I have to now find this resistor in my bin if I have any. So what I've done, what I found, I have a 22 ohm one of these resistors, 1/8 type resistor, 1/8 watt type resistor, and I have a 0.18 ohms 5%, 5 watt. This is what you call Frankenstein fixing. Now this is temporary, of course, because I don't have the component. I'm not here to repair inverter, so it's not like a regular job, so I don't have the proper component. If I do want to go into fixing inverters, I would start to buy components that would be bad all the time. So so this resistor became open circuit. I don't have a 0.1 ohm, 5%. I think it's 1 watt or 1.5 watt. I replaced it with 0.18 ohm, and it's good enough to power this system if I did this correctly. Okay, let's see what happens when I turn the power on. Nothing still. Something still broken. Yeah, I forgot to connect the harness, so when I press that button, nothing happens. So let's see. There you go. Now it's working. So it's giving me E02. So what is E02? Okay, well, I'll go to YouTube and see what is E02. E02. What the hey? Or maybe because, because what? Anyway, for the moment, it seems to be okay. So if I put the power supply, the battery, I'll see what happens. Before I do that, I'll check what is E02 is. So I quickly checked the YouTube. So E02 has to do with these MOSFET drivers. It appears that I have to replace about, let's see, 1, 5, 10, 20 MOSFETs. So now I have to check. I mean, I don't have to deciding how to approach this. I have a limited budget. However, fixing this MOSFET is fairly trivial. I wonder why it would have been damaged. I guess being rained on did a lot of damage to the system. So okay, so I did a Frankenstein. I have to buy the proper component for this. Now I have to do some minimal check on these MOSFETs. It seems like when I was watching the YouTube, all of these MOSFETs are replaced. So watching the YouTube again, it seems like these are also components that are damaged. Kind of frustrating. So it look like there's a method to test them. Don't know how lazy I am. So even with the battery, it's still giving me error 02. So most likely maybe it's the driver that's creating the problem. So these MOSFETs are IRF 1404. So 20 of these needs to be replaced, and then I need to check this driver and then the driver for these transistors. So that's the driver. So sadly, watching YouTube, they don't list the part number that they use to replace component, which is typical. They do that to hide the part number so that people will have a hard time finding the same component. I don't know why. Instead of helping people like me to easily go buy components at Shopee, they don't tell you what the part number is. They just want to show how smart they are to repair components or repair inverters. Yeah. Whereas I'm not interested in hiding the parts. I always list the part that I use, because people like me, we don't make business in repairing inverters, just to mainly make videos for education. So I'm going to check the data sheets for the driver, and then use the appropriate components for the MOSFETs to drive the other MOSFETs. So we'll see how that goes. So it's kind of hard to find the part number for these drivers. I'm going to order parts from Shopee for these two chips, and a resistor to replace that, and the and this IRF 1404. So I am going to throw the scope at this and see what happened. Anyway, this is the state of this inverter. Thanks for watching.